In this video, we will learn about the chain rule, which tells us how to compute derivatives when dealing with a composition of functions. For this, we will review first compositions and detecting functions that are a composite of two functions before we move into the formula. Let's start working with this example. So we have f of x to be x to the 1/3 and g of x to be equal to x squared minus 2x plus 4. So they're asking us to find the composition of these two functions in different order. The first one is f composed with g, and the second one is g composed with f. So let's do this. In the first example, we have that f of g of x is equal to f evaluated at x squared minus 2x plus 4. And remember, f is x to the 1/3. So this will be equal to x squared minus 2x plus 4, all that to the power of 1/3. Another way of doing this is to say this is g of x to the 1/3. So in the end, we will get exactly the same. If you prefer working from the outside to the inside or from the inside to the outside, it's up to you. You can choose whichever method you prefer. Let's move to the second one. In the second case, we have that this is g of x to the 1/3. So this is equal to x 1/3 squared minus 2x to the 1/3 plus 4. Another option is to say that this is equal to g of x squared minus 2 times g of x plus 4, which is working from the outside to the inside. But this again will be exactly the same. So we will have x to the 1/3 squared minus 2 times x to the 1/3 plus 4. In the second problem, we have to work backwards. So this problem is asking us to rewrite this function f as the composition of simpler functions. So this might be a bit more complicated, but it will be essential when doing the chain rule. So let's start with the first one. In this case, we have that f of x is equal to 1 over the square root of x cubed plus 4. So maybe two functions that appears here are g of x equals 1 over the square root of x, and h of x, which is equal to x cubed plus 4. Then, with these two functions, f of x can be written as g evaluated at h of x. So here we found two functions that the composite of them is our function f. In the second example, we can see that the functions involved in this composition are the following. So g of x will be equal to x to the 16, and h of x is equal to x plus 5. So with these two functions, we can see that f of x is equal to g evaluated at h of x. So we found two functions that are simpler than the original one, that the composition gives us our original f.